Well, good morning and happy Monday, everybody. For those of our classes that joined us last week as we did our Epic Climate Fest, welcome back. It was 22 programs in 5 days doing a deep dive into climate change, one of the most epic program series we've ever done. So thank you guys so much for coming in live and on YouTube throughout the course of the week. We reached over 10,000 kids around the world in just 1 week. So really exciting to have you guys in and excited to dive back in with a very different topic today. We are going to learn together about black holes. And I'm going to introduce our speaker in just a minute, but I want to say we had so much interest in this program. Over 120 classrooms from around the world registered for this, that we're going to do something a little bit different with the Q&A today. You're, of course, welcome to share questions on YouTube, but if you want to share your questions and upvote your favorites, make sure those best questions get answered live on camera today, head to slido.com with the event code BLACKHOLE. So I'll put this in the YouTube chat bar as well, but slido.com, event code BLACKHOLE. You can share your questions, upvote your favorites, and take part in some interactive polls and quizzes that we are going to be doing in just a minute. So I hope you guys get a chance to do that. I'm going to dive in with our speaker in just a minute after a little fun introduction video. But we are joined today by Tom Vassos, and he is one of the most popular speakers we have on this broadcast. He's done a bevy of space topics in the past, but today we're going to dive into these gargantuan black holes. What are they? How do they form? What do they do? Do you get spaghettified when you go into them? We're going to learn a lot of cool things like that today. I'm very excited, and I hope you guys are as well. So let me play that brief intro video, and then I will bring in Tom in just a second. Here we go. Tom was kind enough to actually make that video for us, which is pretty exciting. And so I wanted to bring him in the broadcast and welcome him in to dive in with the talk. So Tom, thank you so much for being here today, man. I really appreciate it.
You're welcome, Jesse, and thanks for having me, and welcome everybody around the world to learning about unlocking the mysteries of black holes today. So I think you're going to have a lot of fun, but I thought we'd have even more fun if we could play a game. For starting things off, I invented a game called the Black Hole Blues, where I'm going to ask you some quiz questions and you get to answer those questions. Now, some of them are going to be fairly easy. Some of them are going to be a little tougher, but don't worry. If you don't know the answer, just take a guess and let's see how you do in playing this game. So let's jump into it, Jesse, with the first question. And those of you watching this on YouTube can answer this question on Slido as well with the code Black Hole. And so the first statement is the gravity of a black hole is so powerful that not even light can escape. What do you think? Is that true or false? Just yell out the answer wherever you are, or answer true or false on Slido. And I'm only going to give you a few seconds to answer these questions. So those of you watching the recording later, you can just hit pause and think about it longer, but I'm only going to give you a few seconds to think about the answer. So is it so powerful that not even light can escape? Yes, the answer to that, of course, is true. This is one of the most defining features of a black hole. Statement number 2, a black hole's singularity is of infinite density and infinite temperature. Is that true or false? And you might have seen this all over the internet, making this statement that it's infinite density and temperature. Do you think that is true or false? And guess what? The answer to that is false. Yeah, a lot of people see that. What is actually occurring here is that Albert Einstein's formulas seem to suggest that the singularity, the center of a black hole, is infinite density and temperature. But what most scientists believe is actually happening there is that Albert Einstein's formulas are breaking down, that there isn't something in the universe that's infinite density and temperature, but we have to come up with a whole new theory of something called quantum gravity that we'll talk about in the future, and we don't have that theory yet. So this statement is false. Black holes last forever. Do you think that is true or false? And guess what? According to a famous astrophysicist called Stephen Hawking, he came up with something called Hawking radiation. And he says that, no, this is false. They don't last forever. In fact, they leak out some stuff, and over billions or maybe trillions of years, even black holes will eventually disappear, evaporate, and disappear. Number 4, do black holes have a big appetite? So if there's something nearby them, will they kind of like swallow it? And by appetite, I just mean if there's something nearby, will it it gets sucked inside the black hole. And the answer, of course, to this is true, that if you get too close to a black hole, you could end up getting sucked right inside of it. Here's another question, though, kind of related to that last one. Most black holes swallow a lot of stuff every day. Is that true or false? And the answer to this one might surprise you. It's actually false. And the reason that this is false is the universe and space is mostly just that, empty space. So 90% of the black holes out there are in the middle of nowhere with not much stuff around them. So there's nothing around for them to swallow. And so you could say that 90% of the black holes out there are on a diet. There's nothing around for them to eat. And only about 10% of the black holes out there are in the center of galaxies called active galactic nuclei, where there is a bunch of stuff around them, stars and dust and gas, and the black holes all are swallowing that stuff, but it's only about 10% of the black holes. Black holes burp after a meal. What do you think? Is this one true or false? Because you might have heard that black holes swallow everything, and the answer to this one is true. Now, it's interesting. How can they burp something out? Doesn't nothing escape from a black hole? That is true, but the stuff nearby the black hole does escape, and I'll show you some animations in a minute on how that occurs. And the final question in our game is, do black holes eat everything around them or throw stuff around the universe like your messy baby brother or sister? You tell me the answer. Is it A, they eat everything that's around them, or they throw their meal around the universe and get really messy? What do you think about this one? And the answer to this one is that they throw their meal around the universe. And I'll show you an actual animation of this to actually prove that out. So thanks for participating in our game, the Black Hole Blues. Tally your results out of 7. And guess what? Even if you got a bunch of those answers wrong, the more questions you got wrong, the more you're going to learn today. So congratulations. Everyone is a winner today in our game of Black Hole Blues. So let's get into it. Today we are going to unlock the mysteries of black holes. We're going to talk about if they're real and what are they and how big they are and how are they born and their parts and are we in any danger and how do you find them and are they messy eaters and how common are they? And we may not have time to get through all of these questions, but in the question and answer period, feel free to ask some things that we don't cover, like things that happen when black holes collide into each other. And do they eat a lot? And how can you tell when a black hole is feeding off something? And what happens if you fall into one? And does it stop time in its tracks? And what are these things called black hole swarms or spaghettifications, and does it even enable time travel? So we're going to possibly get into a lot of subjects today. So let's start with just a basic view of what a black hole is. Now, this is just a view, a picture from the Hubble telescope of a bunch of stars in the sky. But what would this view of a whole bunch of stars look like if there was a black hole in between us and a bunch of stars in the sky? Well, it might look something like this. There's the black hole in the middle, and the gravity of a black hole is so powerful that not even light can escape. And as a matter of fact, that's what you see in the middle there, that it's totally black. But guess what? You're seeing some weird stuff going on around the outside of the black hole, and that's a bunch of bent starlight. And that's not that the stars behind the black hole are all bent, but it's just that the black hole's gravity is so powerful, it's bending that starlight. And it's kind of like being at a circus, one of those funhouse mirrors, and you can see the bent starlight all around you. Okay, what are the parts of a black hole? Let's get into that. Here's an artist's animation of what a black hole might look like. And so in the middle here, we've got that thing called the black hole singularity at the very center of the black hole. The edge of that black part is the event horizon. So once you go past the event horizon, you're never coming back out of that black hole again. And then we have this circular shaped thing called the accretion disk. It's kind of like shaped like a pizza, and it's swirling around the black hole at near light speed. And it could be over 1 billion degrees. So it really heats up because of how fast it's moving. And guess what? There's these things called a relativistic jets that's shooting up above the black hole and down below the black hole. And that's the stuff that's escaping away from the black hole. It's not stuff inside the black hole that got away, but just stuff near the black hole that's streaming away because of a whole bunch of very powerful magnetic fields around the black hole. And here's an actual animation of a black hole of what it's looking like. The accretion disk you can see is swirling around the black hole. Now, I just told you a minute ago that the accretion disk is shaped like a pizza. But when you look at this animation, you're probably thinking, well, that doesn't look like a pizza, Tom. It kind of looks like a soccer ball and a pizza. The accretion disk is on top of the black hole and below it and all that. And it's actually not. It just looks like that because that pizza-shaped accretion disk, the black hole's gravity is so powerful that it is bending the light above and below the black hole. So above the black hole, that is the backside of the accretion disk that you're actually seeing, but it just looks bent. And so as a matter of fact, if this was a pizza swirling around, you would see the pepperonis flying across the top of that. And this part on the bottom here would be the bottom crust of the pizza that you're actually seeing because the black hole is bending that starlight. So cool. Are black holes real? Yeah, as a matter of fact, you probably heard a couple of years ago, the first ever picture of a black hole was actually taken by the Event Horizon Telescope. And there's the supermassive black hole in the middle, and there's the accretion disk outside, around the outside of the black hole itself. And this picture is so cool because guess what? This picture, this black hole is actually 55 million light years away from us. That means we're actually looking back in time. This is not a picture of the black hole the way it looks right now when we just took this picture, but this is looking back in time 55 million years ago to the way it looked 55 million years ago. So it's kind of like we're time travelers looking back into the past to see how this thing looked. And guess what? Just fresh off the camera this week, the Event Horizon Telescope team just released this recent picture of a black hole, even more accurate than the first one they took, that even shows some of the magnetic fields around the black hole, that shows these powerful magnetic fields that exist around the black hole. How are black holes born? Well, guess what? Here's an actual animation to let you take a look at what they look like. Okay, so this is how a lot of black holes are born. They are born from a supernova explosion that spills its enriched guts out into the universe. This is one that exploded almost 1,000 years ago, as identified by Chinese astronomers. It was the brightest thing in the sky for several weeks. You could even see this as a bright star even during the day. That's how bright this supernova explosion was. And this is how small black holes are formed. What happens is the star runs out of fuel, it collapses in on itself, creating the black hole, and then it explodes out into the universe. And now we can see this thing called the Crab Nebula. Now, in this particular case, this star wasn't actually quite big enough to create a black hole. In fact, in the middle of the Crab Nebula is something called a pulsar, a different kind of star. But this process is the process that actually occurs when a black hole is formed. So what can you make a black hole out of? You can make a black hole out of anything. So for example, if you were to take our sun, which is over 1 million kilometers across, over 700,000 miles across, and squish it down to about 3 kilometers, smaller than the size of a city, it would become a black hole. Or if you took our entire planet Earth and squished it down to the size of a marble, it would also become a black hole. Not only that, but even you could become a black hole if you squished yourself down to 1/10 trillionth of a centimeter, even smaller than a proton. You could even turn yourself into a black hole. So squishing yourself down that small isn't easy to do. So don't worry, you're probably not going to turn into a black hole yourself. Okay, how big are black holes? Let me show you some samples of different sizes of black holes. So the first size of a black hole is something called a stellar mass black hole. And it is typically about the size of a star, 3 to 50 times, let's say, the size of our sun, which is called a solar mass. And here's an image of one. There's a black hole in the middle of this microquasar here, and it might only be roughly the same mass as a sun. And in this particular case, it's actually eating a companion star that you can see beside you here. And we'll talk more about black holes eating stars in just a minute. The M87 galaxy that I just showed you, that's also a supermassive black hole. Guess what? It is big enough not only to swallow up all of Earth or all of our sun, but it's big enough to swallow up our entire solar system. This is Pluto's orbit here. So this black hole, if it was where our sun is, would literally swallow up our entire solar system and everything in it. And this particular black hole is 6.5 billion solar masses. That means it weighs as much as 6.5 billion of our suns. But that's nothing, because this ultra-massive black hole that we have now found, called TON 618, is as massive as 66 billion solar masses. This one is gargantuan, okay? And so we had to come up with a new name for these ones, and now they're called ultra-massive black holes. How do you find a black hole? All you have to do is get yourself a great big observatory like this David Dunlop Observatory in Richmond Hill. I encourage you to visit this and go to the events at the David Dunlop Observatory once they open back up again. And a cool history on the search for black holes is that a researcher, an astrophysicist by the name of Charles Thomas Bolton, who was a student at the University of Toronto, made some major contributions towards discovering the very first black hole called Cygnus X1, which was actually discovered almost 50 years ago. How did he discover it with the observatory? A black hole is black, you can't see it. So how did he discover it? Well, looking at this picture, you might think, oh, he saw the accretion disk. It was probably bright enough for him to see. And that's not the case. This accretion disk was not bright enough to see in his telescope, but this black hole happened to be lunching on a nearby star. And what was occurring is when a black hole and a star are rotating around each other, they're basically wobbling back and forth. And what he saw was the star wobbling back and forth. And as a result of that, we knew for sure that it must have been wobbling around something as big as a black hole. Now, another thing you can do to find a black hole is just go to the center of various galaxies that are out there. Because guess what? Supermassive black holes are in the center of almost every galaxy out there, like the Milky Way galaxy. So, for example, this particular animation here that I'm just about to show you is the search for a supermassive black hole in the middle of the Milky Way galaxy. It's not big enough to see, but we can see what the stars are doing at the middle of the Milky Way galaxy. So at the middle of the Milky Way galaxy is a spot called Sagittarius A star. It's not a star, but for 20 years, scientists have been analyzing the motion of the stars. And look at this. All of the stars are rotating right around that one spot in the middle. And because they're rotating around that one spot, that's how we discovered that there must be a supermassive black hole there with a mass of about 4 million of our suns. And this is actually an animation of those stars at the center of the Milky Way galaxy. Sorry, not an animation, a time-lapse video where there's the black hole in the middle and you can see those stars just whipping around the black hole. That's so cool. What do black holes eat? They'll basically eat anything that's nearby. So they will eat planets and moons and stars and other black holes and dust and gas. They're not very picky eaters. So if it's something nearby, they will eat it. And here's an example of a black hole swallowing up a star, as in you can see in this NASA animation. It literally just sucks it right in. And in this case has eaten up almost the whole star. And there you can see some blue things. Maybe that's a bit of the burp that's happening, that not everything falls into the star itself. Do black holes eat everything around them or throw stuff around the universe like your messy baby brother or sister? Yeah, they're very messy. And let's take a look at an actual picture of what happens when a star is flying towards a black hole. Most stars that are flying near black holes don't fly straight into the black hole like that animation I just showed you. They kind of miss the black hole. But what happens as the star gets closer and closer to the black hole, that star turns into something called a squeezar. The black hole's gravity, it's so powerful that it literally squeezes the star into that shape. And then when the star gets really close to the black hole, it literally spits it out and throws it off in all kinds of directions. And this is called a tidal disruption event. So it doesn't eat the whole star, but literally a lot of it gets thrown back out into outer space. Let me show you an actual animation to see what that would look like. This is a supercomputer animation on the top left, and a zoomed in image on the right of that star going close to the black hole, which is that blue circle in the middle. And look at that. It's not eating very much of the star at all, is it? It's literally just throwing it on the floor and against the walls and all that kind of stuff, just like your baby brother or sister, or maybe you when you were a little bit younger. And here's another example of that. Here's a gas cloud that got too close to the black hole at the center of our Milky Way galaxy. It's that orange blob there. Look at it. It's following that arrow. It goes right past the black hole, and then the black hole tears that cloud apart. And most of it just flies off into space. But as you can see, the black hole is swallowing some of that gas cloud. Do black holes eat a lot every day? No, like I said, 90% of the black holes out there are on a diet. There's not enough stuff around for them to eat. But they will eat stuff if it is nearby. Let me give you an example of the hungriest black hole in the universe. And it is definitely this one here, this black hole. It's an ultramassive black hole that actually is the size, let me see what the size of that one is, 40 billion suns, so 40 billion solar masses, and it eats equivalent to the amount of 3 million Earths every single day. Now that is one hungry black hole, okay? How can you tell when a black hole is eating a lot? It lights up like a Christmas tree. The friction in that accretion disk gets so bright that it is just visible across the entire universe. This is a black hole whose accretion disk is so bright that it's as bright as 300 trillion of our suns. Now that is bright. And in fact, this particular galaxy is in a class of objects, very rare, called hot dust obscured galaxies, or hot dogs for short. So astronomers have a bit of a sense of the humor. We're going to call these things hot dogs. So that's a bit of a fun side note for you. And finally, we can also tell that they're eating because they burp. That's right. As you can see from this animation here, those relativistic jets are actually going to be shooting things outside of the actual black hole. And when you actually see those relativistic jets, and we see it in X-rays, and we can actually see these kind of like burps, not coming from inside the black hole, but just coming from near the black hole. And that's what we're actually seeing in this example here. And just recently, a major discovery was made around the Milky Way galaxy. There's the Milky Way galaxy around the middle, all those stars in the middle of this picture. But astronomers have discovered giant gamma ray bubbles, which we believe is from a feeding frenzy that our black hole must have had several million years ago. And we can see in this false color image here, the result of this burp above and below where that black hole was on a feeding frenzy many millions of years ago. Let me skip that one here, but I'm going to jump to the final question, or the final two. What would happen if you fall into a black hole? They actually have a scientific term for it. It's called spaghettification. That's right. If you fall into a black hole, you would be spaghettified. The gravity is so powerful that it would literally stretch you out and pull you into the black hole, starting with your big toe, one atom at a time, and literally crunch you up into the middle of that black hole. Which then begs the question, how common are black holes, and do black hole swarms exist? And NASA has just made a major discovery that they have found thousands of stellar mass black holes near the supermassive black hole at the middle of the Milky Way galaxy. Every one of these circles here is all of these black holes that have been discovered in the middle of the Milky Way. Not only that, but scientists estimate that there's many as 10 million to a billion black holes in the Milky Way galaxy alone. So imagine how many there are in the entire universe, that these things are all over the place, which really begs the final question. If there's a billion of them in the Milky Way galaxy, are we in any danger from being eaten by a black hole? And the good news is, no, we're not. In fact, the closest one to us is about 130 light years away. Now, that doesn't sound like much, 130 light years, but guess what? That's over 1,000 trillion kilometers, or over 700 trillion miles. So in the next few billion years, there's no risk of this black hole showing up and eating us up. So we are all safe. That ends what I wanted to cover today. I know we're not going to have enough time in all the Q&A session to answer all of your questions. So please, if you have questions that are unanswered today, feel free to submit those questions to me. Feel free to give us your feedback, especially the teachers out there, on whether or not you like today's session. And if you want to give a great exercise to all of your students, get them to draw a picture of a black hole and maybe one thing they learned about black holes today. Feel free to email that to us at tomvassos@yahoo.ca. Mention the first name of the student and their age and city and state if you like. And with that, that closes what we wanted to cover today, which gets us, Jesse, into our fireside chat, and we can open it up to questions from the audience. Jesse, back over to you.
Fantastic, man. Well, thank you so much, Tom. That was awesome. We'll leave that fireside chat up for a little bit, and we'll dive in with our questions with our live groups. We've got 4 live classes with us, and then so many of you have been sharing on Slido and YouTube, and that is amazing. Over 110 groups watching right now from around the world. Welcome into all of you guys, and I hope you all enjoyed that as much as me. So Tom, you're going back to the slide deck. Get back that fireside chat up, or we can come out of screen share and join us.
Okay, let me do that. Sounds good.
And we'll see you. I'm going to start with Mr. Shattuck's class. They're joining us in Chalk River, Ontario. If you want to kick us off with a question, come on in.
Hi, I want to know if there has been any evidence of what's on the inside of the black hole.
Okay, a great question. What's on the inside of a black hole? No, we have no idea, because the event horizon hides anything inside the black hole. So we have never been able to see anything in there. And even if you went in there and were able to figure it out, you would never be able to either get back out to tell us, or you'd never be able to send a radio signal to communicate to us to tell us. However, there is a bunch of scientific theories, mathematical formulas that suggest what is inside the black hole. And that is that a black hole heads to the very center point called the singularity. So everything heads into that singularity point that gets more massive and more massive and more massive. Now, there's a few other theories that are really interesting, even one by Albert Einstein, that he suggested that not only is there a singularity in the middle of the black hole, but all the stuff that goes into that singularity might go through a wormhole and out into the far side of the universe, into something called a white hole. And all that stuff that's going into the black hole gets spit out into the other side of the universe. And there's actual mathematical formulas that prove that's what might be happening. But we have never been able to observe the inside of a black hole to determine whether or not that is correct. We've never witnessed a wormhole. So right now it's just a theoretical construct on paper, but maybe in a few hundred years or something, we'll figure out that they really exist.
Very, very cool first question, guys. And I want to take the number 1 question on Slido to go in next, and then we'll go to Miss Dunlop's class live. So Miss Snow's class wanted to know, is there anything black holes can't suck up, and does NASA or any other space organization have plans to send satellites into a black hole to potentially get that information, of course?
Okay. So no plans at all to visit any black holes or anything like that, because they're just so far. I mean, we can barely get out of our solar system because the universe is so big. So for us to even think about reaching something trillions and trillions of kilometers away, it's just not on any radar screen. However, after Stephen Hawking died a few years ago, we did send his voice out to the nearest black hole as Hawking, but that signal of his voice to that black hole is going to take trillions of years to get there. So yeah, we don't have any hope of visiting these things anytime soon, except in science fiction. So watch the movie Interstellar, and you can see what happens when you visit near a black hole, what it looks like, and what happens when you get back to Earth after you've taken that journey.
Yeah, it's classically a really, really well done sci-fi film for sort of illustrating the concepts that Tom's been talking about. But yes, distance is something that a lot of classes get wrapped up in space. And I mean, for us to get to Mars, our closest planet, literally like our next door neighbor in the solar system, takes months of space travel at our current rate. So to get to the nearest even star, never mind black hole, would take thousands of years at our current rate. So longer than we've even had technology, had these sort of concepts and ideas. But it's a really neat question. So thanks, Ms. Snow. Let's go to North Agincourt. Let's go to Ms. Dunlop's class. If you guys have a question for us, come on in. Hi, guys.
Hi, yes. We're a little bit shy here, so I'm going to ask the question on behalf of the class. And they would like to know, what's the lifespan of a black hole? So how long does a black hole live for?
Okay, so the answer is a long, long time. Okay, so right now, almost every black hole, pretty much every black hole in the universe is actually growing because of the stuff that's floating around. Even the ones that are in the middle of nowhere, there's still atoms kind of flowing into it. But once this thing called dark energy is pushing the universe to expand, stuff is getting farther and farther apart, then there won't be anything around those black holes at all. But even when that's the case and Stephen Hawking's Hawking radiation starts to kick in where black holes start to evaporate, even then it will take somewhere between hundreds of billions of years or trillions of years before those black holes evaporate into nothing. So we get to explore them for years and years to come.
Cool question, guys. Miss McRae's class is joining us down the 401 for me in London, Ontario. If you guys want to come on in and unmute your mic, share with one of your questions, you are good to go. Hi, Miss McRae.
Hi. So we had a question about white holes. Are those real? And then the next question we had was, is there such a thing called a fire black hole?
Okay, so I'll take that one first. A fire black hole, I have never heard of that term. Maybe that refers to a black hole that's on a feeding frenzy, but I've never heard that specific term. The real term for a black hole that's on a feeding frenzy is that it's in the center of something called an active galactic nuclei, with the accretion disk and the jets flowing out and all that kind of stuff. And the first part of the question regarding the white holes, so that's the thing that I said, that the stuff going into the black hole might go through a wormhole and shoot out into a white hole somewhere else on the far side of the universe. Now, if that was the case, you'd think we would see white holes from where we are. Maybe the black holes on the other side of the universe are spitting stuff into a white hole, and we should be able to see them from where we are. But we have never seen any white holes. We've never seen any observations or evidence that they exist. So many scientists believe that although on paper they might exist, chances are that they might not exist at all. And we certainly haven't seen evidence of them yet.
Yeah. Very cool question, guys. And thank you for that, for clarifying the white hole. But we've got a lot of questions on YouTube and in Slido on that as well. Miss Plant's class joining us in Mississauga. Grade 6 is in the classroom. So nice to have kids in classes. Come on in, unmute that mic, and you are good to go.
How far away does the gravity of a black hole still affect things from?
Okay, so how far away does the black hole's gravity affect? So here's an interesting thing about Albert Einstein's formula for gravity, is when you're calculating the gravity that an object has, it actually goes out to infinity. So even something on the far side of the universe feels the gravity from a black hole. But guess what? Once you get a few tens or a few thousands of light years away from the black hole, the gravity is so minuscule that you don't really feel it. But think about it, in a galaxy where there's 100 billion stars orbiting around that black hole, they feel a little bit of the gravity of the black hole, plus they feel the gravity of all the other 100 billion stars that are orbiting around that galaxy. Okay. And so the other thing is, you saw that animation I showed you of the stars that are just a few light years away from that black hole. They're really feeling it because they're whipping around that thing. But even they're really close. They're only a few light years away, but the black hole isn't sucking them in. It's allowing them just to orbit around the black hole, just like planets orbit around our sun. So the stars are orbiting around that black hole. And guess what? When they're whipping around that black hole, when they get kind of at the end of it, that they're really close to it, some of them are whipping around the black hole at like 8 or 9% of the speed of light. Very fast. So that's the answer to how that gravity affects things around it.
I'm really glad we got a gravity question. We've done black hole presentations in the past, and I want to stress, and you can confirm this for us, if our sun were to disappear and be replaced by a black hole that was the exact same mass, so no bigger, nothing would, I mean, it would change. We wouldn't get light anymore from the sun, but it's not like we'd suddenly plunge in right into the black hole. We'd keep orbiting the same way we were orbiting, correct?
Exactly. The gravity of a black hole has the exact same characteristics of a star. So like you said, if it replaced it, that black hole would be in the center of our solar system. We wouldn't even know the difference other than we wouldn't get sunrise and sunset anymore.
Which is pretty bad. We want sunrise and sunset. They're pretty important here on Earth. I want to take a couple questions from our YouTube and Slido groups, and then we'll go back for another round with our live classes. So Ms. Wagner's class wanted to know, do black holes travel, or is it just the movement of things being sucked into it? So a black hole in the universe distantly, is it moving in any fashion or not?
Yes, so they are moving, and most of them are moving in concert with the rest of the stars in their galaxy. Guess what? Our black hole and our entire Milky Way galaxy is actually flying across the universe at 2 million kilometers an hour. Okay, so they don't really feel that motion because they're mostly just feeling themselves orbiting around the black hole itself. So they're moving in concert across the universe. But here's another cool thing. As an exception to that, there was a recent case of a galaxy, I think it was called CID 42, where two galaxies were merging, the black holes together merged, but because of the gravitational waves that got formed, like the waves in a pond, when those two black holes got merged, they got gravitationally slingshotted right out of that galaxy. And now that supermassive black hole that got formed is flying away from its galaxy that it used to live in. So it used to be in the middle of the galaxy, and now it's flying at millions of kilometers or millions of miles across the universe away from its galaxy. So it's kind of like it got kicked out of its home and it's off into the distant space. But other than that exception, most of those supermassive black holes hang out in the middle of their galaxies.
I love that question. I love highlighting this in space, that pretty much everything is moving. I mean, on the planet right now that we're sitting on, we don't feel that we're going, I think it's 1,000 kilometers an hour, but we are as we're orbiting around. And the Earth's orbiting the sun, and our sun is orbiting the center of our galaxy. There's so many movements happening, but it's relative motion. It's how, you perceive that. Just like if you're in a plane, you don't feel like you're going 700 kilometers per hour, but you are.
Yeah. In fact, not only that, because of that, Jesse, every night when you go to bed, by the time you wake up in the morning, you have already gone a couple of million kilometers across the universe. So sweet dreams to everybody on the call.
I wish my Fitbit would chart that. Let's take one more question from Slido, and then we'll go back to our live groups to wrap up. So Emily wants to know, what's the closest black hole to the Earth? I think you might have covered.
So that's the one I mentioned, which was 180 or so light years away. And there's something like about 3 dozen black hole candidates that we think are within a couple of 100 light years of the Earth. So there's a bunch of them around, and we're trying to track them and find out where they are and learn more about them.
Yeah, super, super cool. Just a question we've been getting a lot, so I wanted to make sure we covered that for everyone online. Mr. Shatter's class, come on back in for us.
Hello.
Hello.
What happens when a black hole eats another black hole?
Oh, great question. So when a black hole eats another black hole, what they first do when those two galaxies are merging together, those two black holes get locked into each other gravitationally, but they don't just dive right into each other. They start swirling around each other and getting closer and closer and closer and closer. And they're literally flying around each other at near light speed until finally they crash together. When they crash together, they release something called gravitational waves, which is like ripples in a pond. Think about when you throw a stone into a pond, you see those waves floating away from that rock in the pond. That's exactly what's happening when those two black holes crash, and those gravitational waves get sent off in all directions. And guess what? We actually have an observatory called LIGO, which can actually measure those ripples in the fabric of space-time that was caused by those two black holes crashing together. And we can actually make those observations on planet Earth to know that these black holes crash together. And they have now found tens of examples of black holes that have crashed together in that fashion. So what happens is you might have one that has 36 solar masses and another one has 29 solar masses. And once they crash together, you can add up those two numbers, and that is roughly the size of what that new black hole will be. Now, it's not quite 1 + 1 = 2. It's a little bit less than that because a lot of that energy and a lot of that mass got used up to create those gravitational waves, those ripples in the fabric of space-time. So that's kind of a cool fact about black holes crashing together.
Ripples in the fabric of space-time is a phrase that never gets old. I want to go to North Agincourt. Come on back in, Miss Dunlop's group. Take us away.
Hi, Junior's question is, if many of the black holes are far away from other things, how do they stay alive?
They stay alive because there's still particles that are floating all around the universe. So they're still collecting up some stuff, but even the ones that are by their lonesome in the vacuum of outer space, that Hawking radiation I told you about, it is such a minuscule rate of evaporation. That's why they're still going to last billions or trillions of years.
I don't think we've ever gotten that question before, so thanks, Miss Dunlop. What a neat one. Let's go to Miss McCrae, and then we'll wrap up with Miss Plant in just 1 minute. Miss McCrae, come on in. Hi there.
Hi. So my class was wondering what kind of education you have and what are your qualifications, and do you work for NASA?
Yes. So the answer is no, I do not work for NASA. I have my Bachelor of Environmental Studies degree that I got many, many years ago. But I think mostly my qualification is that I have spent decades immersing myself listening to the absolute smartest astrophysicists in the world, like Albert Einstein and Stephen Hawking and Carl Sagan and others. So a lot of times when you ask me a question, I have no idea the answer. That's not my answer I'm spewing out. That's the answer that these really smart people like Albert Einstein would give based on the documentation we have and the mathematics involved in all that kind of stuff. So I look at myself more as an expert in communicating these very complex topics so that regular people out there can understand them.
Yeah, we're getting a bunch of new questions for you, Tom. I love that. So thanks, Miss McCrae. Well, let's wrap up, guys, with one more question. Then I'll highlight how you guys can learn more. Miss Plant's class, if you guys want to wrap us up with one final question, go for it.
Scientists or astronomers observed planets being swallowed by black holes.
Jesse, could you repeat that one for me?
Yeah, have astronomers observed planets being sucked into black holes or eaten by them, basically?
No, not observed. But once again, we have a lot of evidence, observational evidence of the remnants of that swallowing that's going on. And so we have that, plus we have the image from the Event Horizon Telescope that at least shows us the accretion disk that's really close to it. We can't get close enough to see the stuff as it's falling in, but we pretty much do have that clear picture now based on viewing it. And by the way, we are only able to do that because most of this stuff is not happening in visible light. Most of those artists' illustrations that I showed you today, you would not be able to see if you got close enough. Most of it is not in visible light, but it happens in X-ray light, in gamma ray light, and other stuff like that. The only primary part you see in visible light is the bright accretion disk that's swirling around the black hole.
Very, very cool, guys. This has been so much fun. And again, more questions that we can possibly answer. So I want to highlight a few things. And I know Tom's going to bring up info about his book as well. But I just want to share Tom's email address on the bottom of the screen. If you guys want to reach out to him, share more questions, get in touch for a paid one-on-one program. Absolutely, Tom is amazing, as you guys learned today. So I hope you guys enjoyed this as much as I did. And I do want to check out and thank all our Slido and YouTube classes for tuning in. Tom, are you going to share that link with me for your book again? That I can.
No, what I'll do is actually right on the YouTube page, I will actually put a link where I'd be happy to give a free copy of my book to everybody, The Ultimate Guided Tour of the Universe. I'm going to post my ebook out there. It has a whole bunch of literally hundreds of videos that you can watch on astronomy and space exploration, TED Talks and TV documentaries and all that kind of stuff. So I'll post that to the YouTube site there, and everyone's welcome to download a free copy.
Fantastic. Well, thank you so much, Tom. And I know, too, you're going to be sharing this with groups after the fact. So I want to say for anyone who's tuning into this for the very first time, who joined in on Tom's program for the first time with us at Exploring by the Seat of Your Pants, we've done over 2,000 broadcasts over the last 2 years. We've been partnered with National Geographic, major government agencies across Canada, and so many incredible partners worldwide. So if you're tuning in for the first time, check us out at exploringbytheseat.com. We'd love to have you guys tune in for more sessions. Tom, this has been so much fun. Thank you so much for spending time with us today. Thanks,
Jesse.
Awesome. I'm going to bring in all our classes, Mr. Shattuck, Miss Dunlop, Miss McCrae, and Miss Plant's class to say a big thank you and goodbye with me. Everybody's now in. Thank you so much, guys.
Thank you.
Have a wonderful day.